Hello, class, and welcome to Module 3. While there are no date restrictions on your modules, focus on completing this before the fourth week of class if you want to stay on a weekly schedule. So what I want to do in this video is go over the overview, objectives, reading materials, go through the supplementary online learning resources, and then go through the activities for this class. The overview. In this module, we will discuss a lot more about the periodic table, its origin, and how it is useful. A key underlining component which flows through the table is electronegativity. The way the table is organized helps you to understand atomic behavior and also molecular behavior. These are the useful trends which make the periodic table a roadmap for predicting chemical behavior. You will also investigate the history and logic underlying the inquiries of the nature of matter. The objectives: understand the history of atomic structure determination, describe in more detail the historical development and practical use of the periodic table, describe the Thomson, Rutherford, and early planetary models of the atom, and explain why the latter is not consistent with classical physics. Describe the way in which Bohr's quantum numbers explain the observed spectrum of a typical atom, understand trends of periodicity, electronegativity, and focus on the elemental group properties, know how to construct and understand the electron configuration of an atom, understand the size of an atom, and give examples of how radii are defined in at least two classes of substances, be able to sketch out the general form of the periodic table and identify the various blocks and identify the groups corresponding to the alkali metals and the transition elements, the halogens and the noble gases. State the meaning and significance of electronegativity and trends visible on the periodic table of elements. Your reading preparation is section 3.4, electronic structure of atoms, and 3.6, the periodic table. So each of these are links to the section in your textbook. All right, and so this one is the electron structure of atoms. So if you look through here, it shows you how the elements are built within the subshells of the electron configuration. So there's the S subshell, the P, the D, and the F. And this is shown in relation to the energies that are associated with them. All right. And so you see, we start off with the lowest energy, which is 1s, to the highest energy, which is 6d. So we go 1s, 2s, then 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, and 6d. So it goes in the order from lowest energy to highest energy, and that's how you want to fill the shells, right? And so if we look at this, this is for hydrogen, the electron configuration for hydrogen. We start with 1s and then it's one electron, because according to the periodic table, the atomic number is 1 for hydrogen, so that is the number of electrons. Remember, we talked about in Module 2 how the number of electrons is determined by the atomic number, all right? So the way that we write this, we put the energy level first because hydrogen is on the first row in the periodic table. It's the first energy level. S is the subshell, and then 1 represents the number of electrons, right? So remember in up here where I talked about we go from lowest energy to highest energy to fill the shell. This is known as the off-ball principle. And so we start with 1s, then we go to 2s, then we go to 2p, 3s, and then we go to 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5F, 6D, and 7P. So that's called the filling order or the off-ball principle. And you can look at it in the periodic table as well. So if we go from left to right and then going from the top row all the way down to the bottom row, you'll see how we do this. So we go 1s, and each box represents an electron. So there'll be 1s1, 1s2. Then we have 2s1, 2s2, 2p1, 2, 3, 4, 5, 6. So this tells you the maximum number of electrons that can go in that particular subshell. 2 is the maximum that can go in S. And if we look at D, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 is the maximum for D. If we saw the bottom two rows of the periodic table in this particular chart, you would see that the top row is 4F and there are 14 boxes. The bottom row is 5F and there are also 14 boxes. So 14 is the maximum that can go in the F sublevel. All right. Here is the orbital diagram. So this shows you how the electrons are placed in the different orbits. So S, it has one orbital and it can hold two electrons in that orbital. And so we use these arrows to represent the electrons. We have an arrow going up, that means spin up, and then arrow going down, which is spin down. That has to do with the quantum numbers. That's not something that we go over in this class, but I just wanted to let you know as you're reading through this to have a better understanding of what that represents. Then if we look at 2p, 2p has three orbitals for a total of those 6 electrons. Remember, each orbital can hold 2 electrons, all right? And so this goes through examples of each of the elements on that, the first 10 elements. So you can look at that and see those correlations. All right. So read through this information, go over the examples so that you can better understand. You'll have more examples in your quiz. So make sure that you understand how to do the electron configuration before you get to the quiz. All right. So the other chapter or the other section of this chapter that we go over in Module 3 is section 3.6, which is the periodic table. You're going to find information on the history of the periodic table, as well as how the periodic table is set up for metals, metalloids, and nonmetals. And then you'll also look at, and we looked at this previously, but remember when I talked about in the electron configuration, the atomic number determines the number of electrons. Remember, that's that top number in the periodic table. The bottom number is going to be your atomic mass. You're going to have your symbol and the name of the element. Keep in mind that the symbol, and we talked about this in Module 2, is either a one letter or a two-letter symbol. If it's one letter, that letter is always capitalized. If it's two letters, like we see here in FE, the first letter is capitalized, the second letter is lowercase. So keep that in mind. And these are the names of the different groups. We briefly went over that in Module 2 as well. The alkali metals are in that first group. Alkaline earth metals are in that second group. The transition metals are in the middle. Halogens, that's over in group 7A. The noble gases are in 8A. These two groups, 5A and 6A, those names aren't as common, okay, but those names do exist. And then the bottom two rows, the lanthanides and the actinides, those are the inner transition metals, is what we call them. The lanthanides and the actinides, remember when we were looking at the periodic table, for the electron configuration. These two rows were the two rows that weren't shown in that periodic table, but these are the F groups, just to let you know. All right. And so go through this, go through these examples. They're really going to help you as you're preparing for the quiz for this module. All right. The next thing that we have in this module are supplementary online videos. And these videos will help you better understand the material for this class. I strongly suggest that you watch these videos because they are going to help prepare you for the quiz and the assignments for this class. So there's an introduction to atoms. There is one on orbitals, okay, what we just looked at in the reading for the chapters. Then there's one on quantum numbers, atomic orbitals, and the electron configuration. So that's going to help you understand that material a little bit better. And then emission and absorption spectra. All right, so we go through that video as well. And then the last one is periodic table trends and bonding. And if you click on that, all right. So when this Khan Academy pops up, they want you to give a gift, but you do not need to in order to access the material. All right. So we are looking at the atoms. There are worked examples of atomic weight calculations, the mole and Avogadro's number, the history of atomic structure, quantum numbers and orbitals, electron configuration, introduction to the periodic table. That's what we are looking for. But the other will give you really good, helpful tips as well. All right, this is going to give you a video on the groups of the periodic table. All right, you can also look at counting valence electrons in main group, and then the periodic table and transition elements. So those are all good videos that will help you understand the material for this particular module. All right. So next we're going to get to the activities. The first one, and this won't come up on your screen, it'll come up automatically in the actual activity. But what I want to do is I want to preview it so that we can look at it a little bit better. There we go. All right, so this is an activity on electron configuration and orbital diagrams. It is an elemental orbital simulation. And so we're going to open that link. But first, I want to go through the purpose and the instructions. So to understand energy levels, orbitals, different notation styles, and to practice building orbital diagrams and writing electron configurations. All right. So it's elementary for a mad scientist, elemental orbital simulations. So the reading sections online, it's elementary for a mad scientist, energy levels, orbitals, and notation styles. Instructions, pre-reading. So read in the order listed the following sections on the site. And then as you read, take notes on how energy levels are defined, the principal quantum numbers, etc., what orbitals are SPDF shapes and capacities, how notation is done, expanded orbital diagrams, shorthand, noble gas notation, etc. Then you want to start the simulation. After reading the notation style, click play now to launch the simulation. Orbital diagram builds. In the simulation, you'll be asked to build 4 orbital diagrams for given elements. For each of the 4 diagrams question, construct the orbital diagram as required in the simulation. Take a screenshot or photo of your completed diagram that clearly shows your labels, orbital, electrons, and that you have built it correctly. The final score page. Once you finish the 4 diagram questions, the simulation will show you your final score. Take a screenshot or photo of that final score. The electron configurations for the following 6 elements. Write a full standard electron configuration and then the noble gas shorthand. So here you're going to insert your pictures for the 4 diagrams and your final score. And then you're going to write out the full electron configuration for calcium, iron, cesium, bromine, tellurium, and then sulfur. And then you're going to do the noble gas or shorthand configuration for radium, lead, and yttrium. All right. So let's look at the simulation. All right. So it's elementary. So we need to first, oops, let me go back here. There we go. So you want to read it's elementary, energy levels, orbitals, and notation style. So it's elementary. Make sure you read through that. And then you're going to go to energy levels. You want to read through that. Orbitals, read through this. And notation style. You're going to read through that. For each of these, you are going to take notes, okay, of each part. And then you're going to click play now. All right. So we want to play. All right. So now, so it says, okay, let's start with an easy one. So we're going to do helium. And helium has 2 electrons. And so we know we want to be in 1s. And we know that we need 2 electrons for 1s. All right. And then once we've done our 2 electrons and it's built it all here, then we're going to click done. All right. So before you get here, okay, you want to make sure that you do a print screen of what you have. All right. So what if there's Yep, because it won't let you go back. All right, so I'm gonna do this one just so that I can show you the print screen. So carbon has 6. 1s, there's only 2 electrons. So then we go to 2s. 2s has 2 electrons. But we've only used 4. We need 6. So we go to 2px. Once we go to 2px, we can only add 1 electron. So we go to 2py and we add another electron. Okay. 2pz is there. And see, it's not going to let you add the electrons. All right. So now we have all our 6 electrons. 1, 2, 3, 4, 5, 6. We want to do a print screen. All right. So when we do that, we're going to highlight what we need to show everything here. And then we are going to paste it. Okay, so if we're actually in diagram 2 because we didn't do it for diagram 1. We're going to paste it here. Okay. When it pastes, okay, it might take a little bit, but it will paste. You don't want it to be so large. It doesn't have to be that large. So you can make it a bit smaller just so that I can visibly see what you've placed in there. Okay. Once you've finished all of the work here, you want to make sure that you submit your work. All right. If you have questions as you're going through, please let me know. All right. And then if you, like on our first one, we didn't take a picture of it, you can always start over again. All right. All right. So we're going to exit preview. We're going to go back to modules. And we're going to see what other activities we have here for module 3. Let's scroll down. I know it's still spinning. There we go. All right, so going back to Module 3. So now there's the quiz. Okay, remember you only have one attempt to the quiz, so make sure that you fully understand the material covered in this module before you attempt the quiz. Next, I want to look at the lab assessment, which is the structure of the atom. And again, it will come up automatically. You won't see that information when you bring up your lab assessment. So I want to preview this. So this is similar to how you will see it. All right. And so for this gives you some more information about the structure of the atom. These are things we've already talked about. But just to let you know, just to refresh your memory, protons and neutrons, they are located in the nucleus. Protons have a positive charge, and neutrons are neutral or zero charge. Electrons, which are located outside the nucleus of the atom in what's called the electron cloud, they have a negative charge. The protons and the electrons, you will find the number of them as the atomic number for that particular element. The atomic mass, when rounded to a whole number, if you subtract the atomic mass from the atomic number, you get the number of neutrons. All right. And AMU stands for atomic mass units. All right. And that's just a unit of measurement for our element. And so if we look at this, okay, we are looking at isotopes in this first section. And isotopes are portions of an element, okay? It's the way to represent the element that has the same number of protons and electrons, but it has a different number of neutrons because the mass number are different, okay? So the mass numbers for isotopes are different. And when we look at the number that's in the periodic table for the atomic mass is calculated based on all of the isotopes for a particular element. And so if we look at hydrogen, hydrogen has three isotopes. It has hydrogen 1, hydrogen 2, and hydrogen 3. Generally, when we list isotopes, we list them as the element symbol and the mass number that's associated with them. In this particular picture, there are just two of the isotopes of hydrogen, hydrogen 1 and hydrogen 2. And this one shows hydrogen 1 as an ion. That negative charge means it's an ion, whether it's a negative charge or a positive charge like we see here with sodium, those represents ions, okay? So if we have, looking at the first one, we're looking at a couple of isotopes of carbon as well as a carbon ion. And so you're looking at protons, neutrons, and electrons and how we determine them. So remember, the atomic number represents the number of protons. The number of electrons is the atomic number as well, unless the charge is positive or negative. If it's negative, we're going to add electrons. If it's positive, we're going to subtract electrons. So for example, if we're looking at sodium Na plus, okay, Na is element number 11, so it's 11 protons, but because it has a positive charge, it won't have 11 electrons, but it'll subtract 1, so it will be 10 electrons, okay? If we look at oxygen, which has 8 protons because it's element number 8, because of that 2 negative, that means it's adding 2 electrons, so we'll have 10 electrons, okay? So that's what you're going to be doing in this section. You're going to go through and answer all the questions based on the different formulas. But there is also a lab simulator, which I want to go through with you as well. because this is going to help you fill in this chart as well as answer these important questions. And then we're going to do another one. So let's look at this one first. All right. And so as it comes up, this is a PhET interactive simulation. And we're going to look at the first one that was listed, which is build an atom. All right, so as you can see here, it says build an atom. So that's the one that we're wanting for this first section. And so we're adding protons, neutrons, and electrons to the atom, and we are forming different elements. All right, we want to see if the nucleus is stable. That means we have a zero net charge, or what happens when we add more or less protons and electrons. So first of all, we're going to start off with one proton, we're going to start off with one electron, and we're going to start off with one neutron. This tells us this is hydrogen, okay? And we want to check nuclear stability. All right, so we know that this is stable. This will tell us the net charge. This will also tell us the mass number. So you want to make sure that all those are showing, okay? You can also look at the cloud view, but we're going to look at the shell view for the purpose of this. So this is hydrogen. So what if we added one more proton? Okay, this would be a plus charge. But this would now no longer be hydrogen, but now this is helium with the plus charge. Okay? So say we took away one of the electrons, one of the neutrons. Now this is unstable. We have a +2 charge. So say we add 2 electrons back. We add 2 neutrons. Now this is stable. Okay, so play around with this. You can hit this to reset everything. All right. And so once you've played around with it, you want to make sure that you fill in this chart with the important information. All right. And then answer those questions. Now we're going to look at this, but the activity for this one is we're looking at isotopes. And so you have the same build an atom program, but now we are looking at the symbol. All right. And so we're going to go to symbol. All right. And so this is what you're going to use for the second portion. All right. And then answer the questions based on that. Once you've completed all of this, you want to make sure that you do submit your work. All right, so going back to Module 3. All right, so that is the end of Module 3. Remember, if you have any questions or concerns as you're going through this module, please let me know. I will see you in Module 4. Have a great day.